Good afternoon to all. Actually, IIIT Tiruchirappalli is organizing a 5 days workshop on design challenges in VLSI and embedded systems or IoT applications, sponsored by ATAL Academy. So, this is a 5 days workshop. So I request all the participants to please attend all the sessions. At the end of the 5 day, as per the ATAL Academy, we are conducting the multiple choice questions and the questions. I request every one of you, you please attend the sessions and gain the knowledge. So this workshop is organized by the Department of EC and CSC. The coordinators are Dr. G. Sitaraman, Head Department of EC, and Dr. R. Dhanlakshmi, Head Department of CSC. Now I request Bhargava, research scholar, to introduce the guest and other things. Thank you.
Good morning, everyone. It's my pleasure addressing you all through this online faculty development program. Indian Institute of Information Technology, Tiruchirappalli, IIIT, established in the year 2013-2014 as an institute of national importance under public-private partnership model by Ministry of Human Resource Development. IIIT is an academic and research institute funded by Government of India, Government of Tamil Nadu, and industry partners. The main objective of IIIT is to achieve world-class excellence in information and communication technology. About FDP, Department of ECE and CSE organizes this online faculty development program coordinated by Dr. G. Sitaraman sir, HOD CE, and Dr. R. Dhanlakshmi ma'am, HOD CSE. The primary objective of this online FTP program is to understand the insights of design challenges in VLSI and embedded system for IoT applications. This particular FTP covers the following topics: architectures of FPGA, features available with Xilinx and Altera FPGA, design of SOCs and NOCs, low power design principles and high-speed techniques, introduction to embedded systems, hardware and software components, pipelining and parallel processing, retiming concepts, folding and unfolding transformation techniques. Furthermore, we are going to discuss IoT basics, challenges in IoT design, and design principles of various IoT applications. So for the next 5 days session, we have eminent speakers from various institutes. Dr. D. Vaidyanathan from National Institute of Technology, Delhi, Dr. M. Bhaskar, Professor from National Institute of Technology, Tiruchirappalli, Dr. R. Gayatri, HR Motivational Coach, Dr. T. N. Prabhakar, Professor, Sri Sai Ram College of Engineering, Bengaluru, Dr. G. Sitaraman, Associate Professor, ECE, Indian Institute of Information Technology, Tiruchirappalli, Dr. R. Kumar, Professor, National Institute of Technology, Nagaland, Dr. S. Murthy, Associate Professor, National Institute of Technology, Tiruchirappalli, Dr. Varun Gopi from National Institute of Technology, Tiruchirappalli, Dr. S. D. Sudarshan, Executive Director from CDAC, Bengaluru, Dr. G. Lakshmi Narayanan, Professor from National Institute of Technology, Tiruchirappalli, Dr. S. R. Balasundaram, Professor from National Institute of Technology, Tiruchirappalli, Dr. Saundra Pandian, Scientist from Ministry of Electronics and Information Technology, New Delhi, Ms. Purnima, Research Scholar, Affiliated College, Trichy, Dr. Venkatramani, Professor, HAG, ECE, National Institute of Technology, Tiruchirappalli. Introducing today's guest, Dr. D. Vaidyanathan, Assistant Professor, Department of Electronics and Communication Engineering from National Institute of Technology, Delhi, has 14 years of teaching experience and 2.5 years of industrial experience. Dr. D. Vaidyanathan has produced one doctorate, currently guiding 5 research scholars. He is an expert in the field of VLSI design and embedded systems. Dr. D. Vaidyanathan has published 35 papers in reputed national and international journals, filed a patent, and published and presented nearly 40 papers in national and international conferences. Now I invite Dr. D. Vaidyanathan to deliver a session on Introduction to Embedded Systems.
Thank you, sir. Can you hear me?
Yes, sir. Yes, sir. It is audible.
Yes, fine, sir. Fine. Good afternoon to all. A small request, and everyone, please mute your mic and your camera also. Please mute your mic and camera. If you have any issues, immediately you can chat box you can fill for me. Okay. Hope everyone it is audible and my presentation is visible. Okay. I request coordinator also, ATAL WhatsApp EC ID also, please mute your mic. If you have any issues, you can unmute the mic. Okay, fine. Thank you all, and sorry that is there will be some delay due to that of some extension in the inaugural sessions. We are going to that of today's session. It's introduction to embedded system. For most things, how much the time is permit, I try to travel this one to some extent. Okay, but some of the things you already knows, and something will maybe a new for that. Since we are running out of the time, I am not asking about that of where are these peoples are coming. I assume that of more people working as the faculty in all over the India. Okay, from the range of assistant professor to some other. Okay. So today, as of that is the topic, the overall topic is VLSI and embedded system for IoT applications.
Sir, Vaidyanathan sir, 1 minute.
Yes, sir.
Still 2 participants are unmuted their video. Please mute your videos.
Yes.
Yes, Rao Ore is still, that video is unmuted. VS Rao. VS. Yes, sir.
Okay, thank you, sir. Thank you. Yes, actually, you see that of somewhere before these VLSI and embedded system purely depend upon that of the technologies. Actually, this is growing very fast for the past 40 years. Actually, because whenever the technologies start growing, technology in sense VLSI technology, basically. That in sense, if you go in depth, the number of transistors in a single IC is keep on increasing. So towards of that means technology, that means VLSI and embedded is growing like anything. I'm not going much about the VLSI because many eminent professors are going to deal on more on VLSIs. But one thing I like to quote over here, that is how the world recognized the VLSI. Okay, as everyone knows. The first IC was introduced. That the first IC in sense, the pioneer who is a co-founder of Texas Instruments, Jack Kilby, he invented. That means he bring the small circuit. Hardly it may be of amplifier circuit in 1958 actually. Okay, but he got the Nobel Prize in the year 2000 actually. So that's saying what I'm trying to say that today. We are unimaginable with that of electronic industry. And in very particular about in electronic industries, we are not unimagined. That is, what are the gadgets we are using today actually. Yearly, hardly you may have the laptops or desktop PCs, and you have a small devices, and it can be used for applications very particular about that of defense applications, or it maybe goes up to that of medical applications. But today, commercial applications that last 30 years is growing like anything, actually, growing like anything. And here that I really thank that of the coordinators. They are making of VLSI and an embedded system for IoT application, because today, due to that of advancement of the technologies, as that of the product developers, they are not saying of my product is embedded, or my product is purely as ASIC domain or SOC domain, like that. They can't say that of, because some part of the things it will be a purely hardware, and some of the part can be controlled by the software by using of processor. That's why what I'm trying to say, it's we can't say that of some product is purely ASIC, but there will be some product ASIC alone. Okay, that different platform, different area it's going on, and some product is purely on embedded. But many products are coming on both. That means one processor, and along with that of some of the hardware, some of the software work can be done by the pure hardware itself. Not an issue. You can learn better after of APGs and other things. I'll go to my topic, introduction to embedded system. Actually, many of them knows about that of what is an embedded system. No doubt about that. But only one thing I like to clarify here: what the desktop processor or a server machine or a laptop, we can't call it as an embedded thing. Other than this, we may call it as an embedded. Why we really going for the embedded system? Yes, the one word, it's about that of automations. Okay, it's one thing. It's one way. It's the automations, because something we have to monitor that can be taken care by the processor along with the few sensors. Okay, and there are different things actually that will be converted version to version, and today it can be extended into, that means if permit, we can discuss something on the system on chip, and then in different type of system also is there. Okay, something we call as a distributed systems, and some extent we are going for the Internet of Things, because 10-15 years back, embedded system using of today also it is using, but more on RFIDs and then wireless sensor network, and today it is going with the Internet of Things, and then we are going like anything actually. And we are going to discuss something about that embedded system design challenges also, and the real-time embedded systems. Yes, just now only I told what is the embedded systems, not like that of what the PCs or laptops or mainframes or any servers are doing. Other than this, it is mainly comes for the development of or controlling of commercial product and some extent of defense and then medical purpose. The embedded comes into the picture. If you say something, I want to make one small product. Okay, in that product, the product size is very smaller in size. I can't make it a very big controller to control the product. That is also supposed to be a miniaturization, must be needed actually. So the lot of design challenges is there, but I try to best of my knowledge. I try to list the challenges and then some of the solutions also. Okay. Yes, sir. Yes, if you see in my room, actually, you can see around your rooms also. So whatever, hardly you have the one PC and one laptop in my room, and I'm seeing this side is AC is there. It is controlled by some hardware. Okay, and backside I have the scanner machine, some hardware. It will be controlled by some hardware, and I have the printer. In this side, if you see that of IP phone is there, and there I have the trasher. I have paper trasher. I have. There are a lot of things over there in and around in my room itself, and somewhere if you are going to see that of in your home itself, you have the refrigerator and the other side washing machine and then micro oven. All our things are controlled by means of some hardware. Okay, so those are all comes under the category of that means either a pure ASIC domain or it may be SOC, but it is very complex. That means very complex in the sense it is really needed for miniaturization. We going for ASIC or SOC. For commercial application, because ASIC and SOC involves more cost involved as of development cost. So we can't go for afford because naturally we are going to put forward of this cost to the customer alone. So we have to think about that offer. But at the same time, mobile phone, I can't go with the embedded. Preferably, I'm going with the ASIC domain, especially SOC domain, because their miniaturization is more important than anything else. Okay. But today we are going with the offer. That's why I'm saying somewhere we are more on ASIC. Somewhere we can go for that means embedded in sense. Surely there will be a processor. It will be receive some signals. That means input from the sensors. For example, you take it off a simple example, a washing machine itself. We are just pressing for 4 buttons. That's all. Nothing else we are giving. So what will happen? Some sensors will be monitoring that water level, and some of the timer is keep on counting, and some sensor seeing that the flow of water is there or not. There are many sensors are there. Again and again, these sensor outputs are given to the input for the controller, and it will be take the decision accordingly. Just an example, and just give the overview alone, just for that of initial understanding. Okay, so what I trying to say that we are today, if you see that electronic industry, that is especially any commercial product, everywhere we are getting it will be a directly or indirectly involving of embedded systems. Just you thinking about, just seeing where you're sitting, just seeing around, and some of them is sitting there we have somewhere we have it of a projector, everything. There are a lot of applications is going with that of embedded systems. Just this is a list of application. It is not limited. The list will be a very bigger list actually. But again, yearly mobile phone size will be of more, and not all the circuits are bringing into the ASIC domain. Some of the circuit are outside also. That not a single chip. We have the multiple chip. Later on, after 95 and 2000, that is miniaturizations is going. That means what? We are bringing of everything onto the single IC. That means we are going on specific application ASIC domain. But embedded is quite having its own advantages actually. I'll come again. I don't want to scattered here and there. Just we are restrict ourselves. We have to go with the list of applications and what is inside that. So broadly defined, if you see that it is not a general purpose computer. Okay, it is combining of that. Everyone says why the name it as embedded. That means software and hardware. Here I like to insist one point that everyone knows it is embedded means software and hardware. But one point I like to insist. I always saying in the class itself, because I will handling the subject more on VLSI related ASIC domains like that, ASIC design like that. One point I like to say that I will say always only with the software. Software is a useless one, because software has to be run by some hardware. Okay, you are writing the code alone. Who is that means you're writing the code means what? You are giving the task by means of some language. It may be of high level, or it may be of assembly, or it may be of machine. Doesn't matter. But we are not going for the machine. Just whatever may be the type of language, doesn't matter. The software alone, it is useless. That's why I'm using a very maybe of a harsh word, but to impact that one, I try to be. Software alone is useless unless there will be a hardware. And again, hardware alone can't use efficiently, or what I'm trying to say, interface we need of softwares. So again, frankly speaking, how I'm saying very harsh about that hardware, software alone is useless. I can somehow we can. With only the hardware as of layman's or as of user end of science, it is also a useless one only. So we need of a hardware that can be controlled. That means can be controlled by means of the software. Actual task can be done by the hardware alone. That's why we need of hardware and the software. Or if you are not getting this point, I can go one more extent of this one. You have the microcontroller, for example, 8051 you have. In that, some of the application I told in my room itself, I have AC in that side, and that side is that of a printer, and it may be of there is a scanner, and then a phone, and then a paper trasher is there. What am I doing? I can use control of all the applications by using of one type of microcontroller, 8051 alone. Doesn't matter. Okay. And then some of the sensors alone, it may be varied, but a basic controller will be the 8051 alone. No doubt about that. Somehow they are now going with the ARM based on the top applications. So how complexity of our application, you are going to select the top the controller or ARM processor or something you are going actually. But a small application, I'm saying that of all the applications can be built by that of same microcontroller. Then what is the difference? Difference is very simple. What type of application you have to control flow will be, specification will be varied. Your type of program alone going to be varied. But the hardware is some input, and then the main part of that one is the microcontroller will be the same. It will control everything. But what is the difference? Software alone is the difference. So there will be a very good flexibility in the that means in the embedded than pure hardware. For example, pure hardware in sense, if you are moving closer more and more of hardware oriented, in sense, if you are going very hardware, performance is very high performance in terms of speed, in terms of power. If you are going for ASIC domain, it's if you are going for FPGAs, or if you are going for the ASIC domain purely, your performance is highly increased. Okay, but at the same time, there will be of that is a flexibility is there. Tomorrow I want to include some more features, so I have to redesign. If you are really did only the hardware based one, for example, ASIC domain or FPGAs. But when I'm doing with the embedded, I have the flexibilities. I don't want to change the microcontroller. Only the thing is that my program has to be changed, and that feature can be involved in that. It can be incorporated. That will be used for the same thing. So embedded have their own advantages, and very important one. The time to market is very important. Okay, when I'm coming to that one later on that. Some characteristics. Okay, don't confuse much about that. One at least of I can say many things, but at least one point you have to take it. Embedded in sense, it consists of hardware and software. But hardware in sense, the main heart of that hardware is that of at least one processor must be there, and along with that of processor or controller, along with that of some sensors and actuators are there, and then input outputs we are going to give. These are all comes into the hardware. To interact with the hardware, we have some programs. Minimum programs will be there. Okay, that is only going to be making of features and other things of the particular product. Okay, fine. That means embedded in sense both the hardware and the software. That's only I trying to insist at this point of time. Okay. Yes, some common characteristics of the embedded systems. As a single program repeatedly, yes, of course. When you're switching on the washing machine, automatically something is going on. Okay, it has to checking off something. That means what? It is start running. The program starts running. If you are AC, you are going to on. Something is going to on. It will be monitor the room temperature and then displaying it. Some display has to come out. Something is monitoring. That means repeatedly, a single program is going to be running in applications. Okay. So what is the first thing? It should be low cost, low power, and small, fast. This is, I won't say always all the parameters you have to concern. It is purely depend upon what type of product. Actually, for example, if you're going for battery operated one, because many places that is we are using the gadgets. That means battery operated electronic gadgets we are using. For their low power is very important. Okay. And if you want to feel that of it has to reach to that of the people who are end user will be of affordable cost actually. For example, if you are making of agriculture oriented some product, for example, one of my researcher working on that means PhD student working on that is smart systems for the better agriculture yield actually. we are going to predict some, we are going to, based on the, that means soil, and then based on the weather condition, we are going to guide that of, that is the people, farmer, that means to make of more yields actually. So there we can't make it of the product cost is higher, because that should be very low cost. Many places the low cost and especially when it is a battery operated low power is very important. And then it should be very handy enough actually. If your product is very bigger in size, nobody is interested just to see that offer. And if you give that offer, that means the speed is also very important. These are the primary parameters. It may be of embedded system or VLSI. Both the things are will be the same. And the electronic, whatever the commercial applications or the even in the any applications, from that of rocket launches to the defense purpose to the communication purpose to real-time communications to the commercial application, these are the preliminary parameters we are working towards. But somewhere we can satisfy or we can sacrifice of some of the parameters to attain the others, because all the time, all the things, if you want, won't be affordable, because sometimes the cost can be drastically increases. Why? Because the cost is increases. When you want a low power, we are trying to bring it off more hardware actually, so that design cost is higher, and the miniaturization is there, and that will the small also there, and it will be increase the performance in terms of speed also, but cost will be higher. Okay, and then flexibility will be lesser. So that's why I'm saying we have to somehow the designers can be going with the top based on the specification, and then target of market actually. Okay, that is also very important. Market is very important. Market in sense where the end users, okay, is very important. So that is the tightly constraints. This is a single functional, and then reactive and the real time. Actually, real time, most of the things we are working now on what's more on the real time applications actually. Okay, so we are going to deal these points very elaborately in the coming slides actually. Not much about that of what is the embedded system. Already we are discussed in the previous slides actually. So it consists of a processor, at least of one processor, along with that of some sensors and actuators. Okay. And along with the hardware, that must be a software also to interact with the hardware. Okay, and that software only have the specifications of what is that of that product as going to be functioning accordingly to the software, but that can be run. Software can be shifted to the hardware also, but again I'm saying hardware, if you're more shifting towards the hardware, that will takes of more time to design also, that will takes of more cost involved also. But it gives the performance, very good performance. If that of if your product consists of more hardware, lesser software, performance is good. Okay, cost is higher. At the same time, if you are lesser hardware and more software, that means burden is given to software, performance will be degraded. You know very well. Actually, the processor or hardware, it will take the inputs as combination of zeros and ones alone. But what type of program we are going to give, that has to be do it in several layers, and it has to be reached and it has to be done. For simple example, if you have the full adder, we feed the A and the B as the input, and we can get the output as set of some Y here. But the same thing, you have to write the program. Okay, that takes sort of more time, and then you can. But only thing is that of this is an example. I'm seeing that often everywhere hardware will be there. But for example, I'm giving, don't stick on that of full adder alone for easy understanding alone. What I'm trying to say here, there is no guidelines or exactly the things. It is purely depend upon the designer, which portion. There will be some software, but how much sort of I can go with the software alone, how much I can go for the hardware alone. That is very, very important one. Purely it is depend. If any product is you are going to design, there is a team of people. They will decide, and this part will be taken care by the software, and this part will be taken care by the hardware. There should be a preliminary hardware. Along with the preliminary hardware, some of the portions we can shift it to the hardware part alone, because we are going to handle the real-time applications. So the speed is a constant. Okay, so there we have to more, but it is not a problem. It is purely depend upon the designers, what is a portion of the hardware and the software. Yes, this is only I try to say something. See here, how it is keep on moving actually. As traditionally, embedded system must consists of at least of one controller. Okay, along with that of some of the sensors. That means input-output devices, and will be there, and it will get the inputs based on. For example, you want to temperature monitoring alone. For example, for a high boiler, we have to maintain the temperature, because if it go beyond the limit, okay, so it will be that means what, it will cause a major accident itself. So we have to monitor the temperature. Just an example I'm saying. So here some manually we can do, but problem is that of we have to put some alarm or some kind of things. Simple microcontroller can be used, or you can use the some general purpose processor alone. I don't want to waste your time. What is the difference between the general purpose processor and the microcontroller? Yes, very microcontroller we can call it as a system actually, because on chip we have the small memories, and then some of the preliminary ports, and then timers, and then serial communications. Some of that things in order to make the system that will be available in a single chip itself. Somewhere we can go for high-speed processors, so we can go for the processor itself. That is up to the, again, this is also up to the designer what type they can go. It is purely depend upon the applications also. Okay, some applications demand the miniaturization. Better you can miniaturization with the low cost. You can go with the microcontroller itself. It's very easy to do. And the third one is today, as we know very well. More, or I think so, many of the researchers also working on this area, so digital signal processing, where MAC unit is very important. That means it may be of, after all, what is the processing in sense that involves of a series of adders and the multipliers. That means MAC unit is more important. So you have the more MAC, okay. That means a normal processor, and then DSP processors. That means the Texas Instruments are doing more on the DSP processors, and you can see that of don't that is a Texas Instrument. They are come with of the DSP processors. Okay, where the MAC are very important, because in order to process the signal or video signal or image as be faster. What I'm trying to say now, you have the camera. In one of the application is a camera. You have the camera. You are capturing the image. As we know very well, today competition is going beyond that things. Even that means mobile camera have the higher resolutions. And then you have to capture the image, and it has to be stored to the memory, and whenever we want to see it, and it will be coming back. So it is very high resolution cameras are there. So these high resolution cameras, higher number of pixels, and each pixels can be represented by the more number of bit representations. What I'm trying to say that if you are stored as such, what will happen? It consumes of very huge area. Memory requires of huge memory capacities. Normally, what we'll do, the processing, just in one example, I'm saying, processing in sense what? You have to capture the image, and then that directly stored into the memory. We want to process that one. Process means, just to take it as a simple example, we have to compress the image, and it will be stored to the top memory. Okay. Whenever we are retrieving that one, it will be decompressed, and it will be stored to that, because visibility also is very important one. So there will be something is going on, directly capturing the image and storing, and we are doing something. So this must be a faster. For example, I capture the image. Okay, that takes up 2 minutes to store into the memory. Then only I can capture the next image. Means who will buy the product? Just try to understand who will buy the product. So fast processing is very important. Okay, as we know, that is many of them doing the research on the signal processing or image processing. We have the filters. We have that is different techniques. Algorithms will be there, but again and again, their major hardware requirement is that of the MAC unit. That means adder and the multiplier unit actually. So that is specially designed for signal and image processing, because which one takes off many times it will be running in your algorithm. That hardware efficiently, if you designed, then overall performance of your product will be of higher. In sense, very fast it will be stored, and very fast we can retrieve the images. So there will be specially designed for MAC unit is be there. It is up to you. You can select off based on the product. Again, based on the product. And then one thing today, actually, traditionally, we are for 25 years back, we are purely working on this area as a embedded. We are not clubbing of this part into that one. Okay, embedded means making of everything. But what I'm trying to say that pure hardware in sense, the algorithm, what you're writing in the software, now it will be shifted into the hardware in sense, in order to increase the performance. In sense, what I'm trying to say now, here you can select the microcontroller or any of the things. Some algorithm can be run by these processors. Okay, these processors run by these processors. Fine. Okay, there may be at least one or two processors. Okay, so that is your algorithms in terms of software. It will be run by this hardware. Fine. Now, what we are trying to do is that algorithm itself can be implemented in the hardware itself. Because of today we are working on the real time, we need of very higher performance in terms of speed, especially in terms of power consumptions. Okay, in terms of real time data handling. So what they're trying to go in that of some portion of the hardware can be converted. Some portion of the software or algorithms can be converted into the hardware itself. That means yearly we find the solution by means of software. Okay, that algorithm. Now we are going to find the same solution with the better performance by means of the hardware. That's why how it is possible. First, because of yearly designing in FPGAs takes off a very bigger one. Why? Because we don't have this much of exposures and other things. But the last 20 years, FPGAs industry is growing like anything. We have the processors, along with that some portion will be taken care by the hardware. We need not to go with the purely ASIC domain to integrate of these two. No need to go like that, because we have the another platform to implement the pure hardware in the FPGA itself. So that will be interact, your performance will be better and better. The next one, that's why a good processing power and then longer, but again it has some disadvantages. When you're going for these methods, by using of only of processors along with some interfaces, we have only the softwares. We can time to market is very easy, because the design cycle time is very lesser. And if there is any problem also, we can just like that, we can change the data. If you want to change the program, and if there is any feature you want to add it off, very easily we can add the features also, very easy. But means this one. But when you are improving the performance, some portion can be we are doing in the FPGAs also. So that takes off a longer time actually. Okay. But again, I'm saying I am correlating with the embedded with the FPGA. But today's purely the whatever the embedded things, that means what with the microprocessor, with the algorithm reading, purely it will be converted to the FPGA itself. That is also possible. Some portion alone it is possible, and purely we are going for FPGAs is possible, and that gives a very good performance. And now we are going for ASIC domain. Actually, for ASIC domain have the very good advantages in terms of performance. And somehow if more demand in the market cost wise also, but it is having its own disadvantages. And some product we can't go with the these methods, we have to go with the ASIC domain only. That is one of the best example where we need of really of miniaturization. Example, mobile, actually first as of some data somewhere I studied Nokia. Now it is the company's it is coming back actually, but they came with the first ASIC in the 70s. That means once that started the VLSI domain itself, later 80s itself, they are trying to come with the entering into the ASIC domain. Actually, ASIC in sense application specific integrated circuit. So again, I'm saying that is the IC can be designed for the particular application. Okay. For example, I call it as a mobile SoC. That means what? That IC can be fabricated for application of mobile. And then camera IC. That means I have that today, you know that the cost of the cameras goes from 1.5 lakhs to, it goes beyond the limit, 15 to 20 lakhs for the commercial cameras also, some of them is using. That means in marriage or that somewhere they're using, not even to shoot the films or other things, but a normal camera itself, it goes beyond the 5, 6, 11 lakhs it's coming. So why I'm saying, what is this one? ASIC have the advantages in sense in terms of performance, in terms of power, in terms of that means speed, okay, in terms of miniaturization. All the things ASIC have the advantages because we are bringing off many chip into the single IC itself. Here, what I'd say, here there will be some processor and software will be there. Hardware means in terms of processor or microcontroller, or it may be of more than one processor. Along with the thing, we have the maybe of DSP processor, we can use it. And then we have some interfaces, hardwares are there. In order to control or interface that, we have the softwares also there. Fine. Okay. But again, some portion of the software is going to be converted into the hardware part that can be implemented using lot of FPGAs. But I don't want anything. I can purely going with the hardware in sense. Purely going in sense, there will be a program. That means we need a software. But all the things which is in the single PCB board, I want to make it into the single IC. Today you can see that of as of you are all the people witness because of maybe of age group, you know that of. You can see that of that is a TV, what you are using, LED TV you are using, and now coming as a smart TV also. Smart TV in sense what they have maybe of many sensors, and you need not to bother about much about that. If you are speaking or make it as channel 4, then it will go to directly channel 4. Just I mean, imagination is the pioneer of that of any research actually. Today I'm saying, tomorrow you can raise your, and even you can give the sign as 4, then it will be changed the channel as 4 also. So what I try is the smart TVs are coming around. And I'm not going into the smart TV, go to the top, the normal, your old TV of CRT monitor itself, and then come back to the LED TV. But it having its own disadvantages in the ASIC domain because all the things, what are the things in the motherboard, we are bringing into the top very, very smaller in size, just like that of in a hand we are bringing off. So what is that? Everything will be put it into the single ICs. Problem is that if that is gone, that entirely thing. That's why if you're going for any repair work or anything, they say the cost is around 5,500 or 6,000. That means nearly of above 50% of the product cost. Why? Because they want to entirely remove the board and they're going to make it as. And the next cost is LED alone. So either of this one is goes, then you have to change the product. That's why there is another problem is coming and in the world for the last 15 years. That means electronic waste actually. Okay. Why? Because of somehow yearly you can see that of that is your TV can be repaired by many shops will be there. At least of 4 or 5 street, at least one person will be there to repairing that of more. But now repairing cost will be more and more. That means somewhat equal 50% of cost compared to that of your product cost. So that will make that of e-waste will be of more and more these days actually. Don't confuse again and again. Each slide, 1 point take off alone. That's all, nothing else. Because single 1.5 hours, I can't make you that of dump everything onto your mind. Things. So I try to give that of the way and how we are going. Either that is your product or your applications find a solution by the processor or controller itself, or controller along with that of some portion, or you going to implement it in the FPGAs, or if you are really going for that of that means ASIC domain, like that we are moving. Okay, just I try to give it of different, but anyhow as of those are the organizer already told you have the special section on the FPGAs also, and then pipelining concept ASIC domain also somewhere in the that is in the near, that means next 2-3 days. Fine. What are the design challenges actually? Okay. Construct and implement with that desired functionality. That is already indirectly we are discussed. That is only specification. I'm saying any product will be start with the specifications. It may be of how we find the solution is different way. First, it will be start by the specifications. The specifications means maybe of client will be given, but client will be given as that of overview alone. As of architecture, design engineers can be go with the detailed functionalities actually. Okay, and then that is we normally knowing of functionalities, that is only we can call it as of specifications. By some of the if you are designing for algorithm, you have to go with the standard specifications. But that, for example, IEEE or something. For example, I'm going to that means pure hardware versus. I don't want to confuse. So functionality in sense, we must know that what is that product is really doing. That is somehow we can refer as specifications. Detailed specifications towards a product that can be make it by the architecture. Okay. And then key design challenges. Okay. That means simultaneously optimize and numerous design matrices. Yes, optimization always we are working, but again and again optimization is not comes in the first release itself. That's why all the products are coming with that of after some years there will be new versions or things are coming for the same product, the same finding the solution for the same product itself. Okay. Okay, we are going to discuss and design metrics. Okay, that means how the systems are implemented, optimizing design metrics, all the things we are going to discuss. Yes. First, before going to the design, while designing, the cost is very important. All the costs are differentiated into the two parts. One is called as the NRE cost, that is a non-recurring engineering cost. Other one is a manufacturing cost. You can, I'm not going in depth of this. This is for both the embedded as well as ASIC, the same platform only. What is our aim is that of based on the that is the product we can go actually. Just at this stage you can say that of NRI cost are nothing but of the design cost. That means one-time cost. Okay, once if you're designed, fine. That will be a manufactured. For example, first you are manufacturing 100 pieces. Okay, it is demand is more, then you manufacture that 500 pieces, then you also demand is more, then we can go for 2,000 pieces, then it demand is more, we can go for 20,000, like that, keep on going. But one time your design cost is involved. So more, please try to understand. As of every time I'm saying while taking off in the VLSI itself, okay, or it may be of embedded, it's a only industry you can get it off good features with the lower cost. Every time I'm quoting of this point because of this one only. Okay, what I'm trying to say now, you can imagine your the first, for example, just an example, you can take it up that your mobile phone itself. For example, your first mobile phone, what is the cost of the mobile phone? And then what are the features you have the mobile phone, including of it may have the camera, and if it is a camera, what is the resolution? Everything you can think about that. Hardly 15 years back, even color mobile phone, it's a very difficult to everyone. But somehow after that means things they have to spend of 7,000-8,000 or even up to 10,000. They have to give it, but not this many features. But today, and then you have to spend at least 3,000 to 3,500 for the normal mobile phone itself. Okay. Now that will be cost is 700, 900 rupees and all, you can get that of the mobile phone. That means basic mobile phone. And if you have that of 5,000-6,000 with the Android mobile phone, you can have that of all the most of the features you are having. But what I'm trying to say, when the days are close, that means what? That this only industry, the cost is reducing. You can't say that of the Maruti 800 cost is, I have the very less features, somehow I have to pay the money, but it is not drastically reduced or increased or they have to manufacturing cost will be more enough. Okay. So it's only industries we can get of lesser cost, more features when compared to the 15 years back. That one example I'm saying, your first mobile phone and what is a mobile phone you're using today. That's all. Nothing else I want to share with you. You just compare. What is the cost of the mobile phone? What are the features you have? And then today, recently, maybe of 1 year, based on that of the person, 6 months or 1 year back or 2 years back, you brought the mobile phone and you're using. What is the cost of that mobile phone and then that features? You can see that offer. And then today, that cost, if you put what is the features, you can get it off. It's only industry. You can get it off a very good feature with the lower cost. Okay. That is the next sizes are important, and the performance. That's why I'm saying the performance is more deal on the top. How much the portion of the hardware and the software and which way we are going to selecting actually. And then power is very, very important because of already I told most of the gadgets we are using are the battery operated one. We are not ready to frequently see every that is the users. They want to using the mobile phone for all the purposes. They are using for all the purposes, not only for communication purpose. They are using for all the purposes. they are reading the news, they are watching the movies, they are hearing the songs. 24 hours they want. That means what? Whenever they're sleeping, all the time they're using the mobile phones, but they don't want to charge the mobile phone. That means what? They need of that means that consumes of lesser power. If I charge for 1 hour, I have to use for 2 days. That much product they want. Okay, that product they want. They don't want the product morning one time you have to charge, afternoon one time charge, evening you have to charge. They don't want that, even though it is a very good features also. So your power consumptions plays a vital role in VLSI also. That's why last 10 years that one area is growing like anything, low power consumptions. The design also moving towards of low power consumptions. Power is very, very important. Flexibilities again and again. If it is more flexible, you can reduce the NRE cost. Why? Because see here, I designed the by using of traditional embedded system. That means what? One processor and other things. So every features can be explained by means of software alone specifications. What we have to do? Only that a program has to be changed and it will be entered into that of the memory. Then the same product has to be, that is the features can be incorporated. Functionality may be a little bit changes. The features can be incorporated. So NRE cost is highly reduced like anything. But if you're going for pure hardware basis, what will happen? So we have to make it of recycle. Again, we have to start from the scratch. Again, we have to redesign the things. The same, we have some pattern, but again, we have to relook into that hardware itself. So the flexibilities, it is more flexible, okay, and then NRI cost is lesser, but performances will be also lesser when you're going for more dependent on the software than the hardware, okay. Please don't confuse. You have to always keep in mind of this slide very carefully about this one. Then you can, whatever I'm saying, you can easily understand. Okay, so that only the flexibility comes. So flexibility is purely depend upon the NRE cost. Okay, so that is if you are easily you can change that of the functionalities, that NRE cost will be lesser. If you take off more time, that means that designing you have to redesign the things, then NRE cost will be increase more. Okay, so this is very, very important. Okay, this is very, very important one. Okay. Yes, sir. The next one is that of time to prototype, okay, and time to market. See, I will see that of today's demand is this product, okay. I did a little bit survey for last 6 months. I'm saying that of if I design for this product for next 2 years, this demand is higher, okay. So I have to come with the product at least by next 6 months itself, okay. That is only my challenge. But if I'm saying that of I'm taking a very longer design cycle, I made a survey today, but my product comes after 2 years alone. How much time you are losing? Don't think so. You are the only made a survey and you are only the person developing, or only the person or only the company developing that product. In the world, many of them are looking into the problems to find the solution. So they also want to bring the product on their own. So what I'm trying to say that of today you decided I'm going to find the solution for this problem. Okay, I'm going to make the product. Okay, so that product has to be come in time to the market. And how much the time you are going to be increases to bringing into the product. Again, one simple example, take it of the COVID itself. If the vaccination comes after 5 years, okay, demand is now only, okay. So they also knows very well, they are also working on the time is a constraint. And now you can see that of if the vaccination comes 6 months back itself, what is that of the cost they can fix it off. If the vaccination comes after of 6 months, what may be the cost, what may be the demand, you just the time is very important. That means what is you made a survey, you made it, we are not going to the medicine, but medicine is a too objective thing because we can't, we are the people are working with the electronics. So it's just for the sake of, that's why I'm saying, I want to give the examples because I have the very bad experience while giving the examples actually. Okay. So, but to easy understanding, I quote the things, but don't compare that of your example with the medical things because that's perspective, their aim and everything will be different. But our aim and objectives are somewhat different, okay? Because I have very worst experience with the, that means the class timing, I will give that of modulation example I given, that person is writing in the paper, that example alone, not the definition of the modulation. Okay, I don't want to waste the time to share it of that one. Very funny things. That's why thereafter I'm not putting more examples actually. Okay, come to this one. So time to market is very, very important. How much that of you are late to release the product into the market, that much the shares you are going to, that means losing. Okay. So for this one, what is the important? What is the important to bringing of a time to prototype and time to market? Your design cycle is involved. Your design cycle. You take a lesser time to design. Okay, lesser time to design. Then after all, your product is coming means what? Design and manufacturing is basically major things. So you have to, first of all, your manufacturing is the second part. It takes off somewhat. We can easily parallelly we are going off that one. What are the components? We have to make the survey and everything. We are developing up one set of something is there. We are making of survey on the hardware part also. So manufacturing is one part, but design, without design, we can't go for manufacturing. So we have to make the design cycle very, very, that means what? Smaller. That means what? We have to complete the design as early as possible. And also then we have to see that of other side, we have to see that of how easily it will be manufactured. That's why I'm saying pure, that means embedded with the microcontroller, microprocessor are very easy to bring into the product. And then with the utmost, if you're going with the FPGAs also, very easy to time to the market. When you're going for the ASIC domain, it has a very good features. That means very good advantages. Okay, but one major disadvantage is that of longer design cycle. And manufacturing also takes a longer time. So it is not that much easy to bring the product. But FPGAs or the in the normal microcontroller based product you are making, it is very, very easy as of FPGA field programmable gate. That means what? You can do it on your field. Okay, you can easily come with that of the solution and then you can easily go for the product actually. So that's why the designers can be make it of that very clear picture. The time to market is very, very important. That means that is directly depend upon the design cycle. Maintainability, yes, of course. This is one thing I like to say that of I selected one microcontroller. How I can select the microcontroller? One point is that of what I'm selecting the microcontroller for my product. That microcontroller must be available in the market at least for 20-30 years. Okay, so that is very important. I chosen some microcontroller. I programmed based for that microcontroller. But after releasing my product, within the product is okay. That means what? It will be of a good reach to the people. But within a 6 month, that microcontroller is not available because that person is shut down their company and then went off. Then how we can continue the product? So we have to be, other things also we have to see that. Then the other things, all the things we have to see the correctness, safety, and other things we have to look into that. Yes, this is one example. We are trying to give it of that. Okay. So nowadays, we are making of this one, we call it as an embedded, and now it will be changed to the ASIC domain also. Everything they are, that means what? The analog to digital converter, JPEG codec, DMA control, everything. Okay. So just we have to buy those things, and along with that, we can integrate and we can make ASIC also. If you are takes off for thing, and then we can call it as that of traditional things. I want to make it of separate ICs, and then I want to integrate. That is also embedded. We can do that one also. Only difference is ASIC domain. It takes a longer cycle. Okay, and miniaturization is more, and performance is good. Power consumption is lesser. But when you go for the traditional, that means what? Yearly method, if you're going for the microcontroller along with the interconnected with the top, all the IPs, that means different ICs will be connected. Naturally, the board of the PCB will be higher, larger in size. Okay. And then performance somewhat will be lesser than that of what you have it in that of the ASIC domain itself. Not somewhat, that will be lesser. Especially power is worst because it consumes more power compared to the ASIC domain. So we have to be think enough. Just one example I'm saying. What are the things you have to see? NRI cost, the cost involved. So normal method cost is very lesser. ASIC domain cost is more. Performance, ASIC domain more cost, very good performance. Power consumption, very good power consumption. Size is very, very good. Very lesser, very compact. But cost is more. And the design cycle is very, very, very long design cycle. You have to decide. which product, which one is that. There will be something I can come with that of after 2 years also, but I have that of things. Keep in mind, my product is that time also the demand may be of very good demand what I made it today. Okay, so we have to think about that one also. Okay. Yes, sir. The expertise with both software and hardware is needed to optimize the design matrix. Not just a hardware or software expertise as common. Design must be of comfortable with the various technologies in order to choose the best for that application. Again, we have to trade off always. Okay, there should be a hardware, there should be a software, but the trade off will be there. Okay. Yes, already we discussed a lot about the time to market actually. Please keep in mind, I have to practice. The slides are for you, not for me. The slides are just for the guidelines. I can speak whatever in my mind alone, but you can incorporate it. But that's why the time to market comes in this slides. You can correlate whatever the things we have discussed earlier in this slide actually. Okay, so how much you are making of delay, that makes it of that is you are losing your market shares actually. Someone will enter into the market, and that product will be that means what, better performance. That means what, even though your product will be a better performance than that product, but that it is already reached to the people. Okay, so you are finding of after of picking time takes longer time. Why? Because one set of you, they want to come out of that, of they want to buy your product, and that feedback will be shared to the other people. Then only they have to come out of that of the yearly product and then come to your product. Even though if your product is much 20 times better than that of already existing product, it is not just like that you can. But when you come into the yearly, okay, this product is the first product that comes into the market. So everyone want to buy the product, and then automatically it reaches, and then they give the feedback, and that goes in a different manner. That's why time to market is very, very important in terms of the business perspectives. Okay. Yes, they have to give the time cycles and the examples they're trying to give it up. You can take your things and you can do it actually. Yes. What are the different classifications of embedded systems? Okay, someone they called as centralized versus distributed time, distributed things, and the real time versus not real time, and then fail safe, and soft deadline, firm deadline, and battery powered versus mains powered, system on chip versus discrete system. That's this simple example I told. System on chip we can make it, or the distributed system we can make it. Only thing is that of the performance, cost, size, and everything will be varied based on that what type we can make it of. Okay, I think so. I'm going a little bit towards because if I keep on talking, it will be goes like anything. Somehow I can go directly of some application oriented because last 40 minutes we are discussing about of more on this embedded system. I don't know how much it will be there. Many of the things you may know also. Somehow we can go for some application oriented actually. So today's applications, if you see that of today's especially of high-end cars actually, okay, there doesn't the safety is very important one than anything else. Safety is safetiness. That's why they have more cameras will be there in front and side views, and then backside also more cameras are there. And other one is that of when they are hit, automatically the balloon will be open, and then we have to see that of any leakages inside that. There are thousands of I'm saying that of hundreds of the sensors will be there, and it can be controlled. Thousands of sensors will be there, and it can be controlled by the hundreds of microcontroller. It will be there. Okay, because we are monitoring everything we are monitoring. Okay, so and because how much we want to see, for example, some of them they will check the pressure also. What is the tire pressures also? They are checking about of each thing, and then there will be a leakage in the fuel somewhere. They have to have the other sensors also, because some extent the cars are yearly here now also. For people, there are different type of customers are there. There are some people, it may be of essential one, and some people they want the essential for the safety also very important. Okay, for example, the people they can ready to afford that of the cost, but the safetyness is very important one. So and then automation is very important. Security is more important. So for these reasons, we can't keep it off people many things to monitor. That's why embedded has to come into that. We have the hundreds of sensors. We have to make it of tens of microcontrollers to monitor of these things. Actually, this is an example I'm saying here. Okay, and slowly it is going up because I'm going. At least I want to touch the top. That is today's topic: embedded with the IoT. Actually, this is going as of with this traditional things actually. One thing I like to say here, I'm skipping and moving towards of this one. Okay, this is one. Okay, yearly, how the IoTs are coming. Just I try to travel in this area. Okay, for frankly speaking, one of my first student, a BTech student, long back, if they came with the RFID and based project I'm doing. Now today, in library to everywhere, RFID is there. Okay, even you are using that of what I called you are using of every just imagine of 15 years back in the cars there won't be of auto lock will be there, and today we have the auto lock, and then if that unknown person, and then more security is that of if the unknown person is going prescribed near to the car also they will make the alarm is there. So and libraries RFIDs or plays a vital role. Okay, so there, that means 15 years back, 10-20 years back, that RFIDs plays a vital role. And then they are going with the wireless sensor networks, WSNs will be there. Okay, we have sensor networks. Okay, and then we are getting of collecting of all the inputs, and then based on that we are that means that central that means the processor will take it of decisions. For example, one of the best examples for in the sea borders we can use that of these sensors. Okay, and we collecting the signals and we try to give the alarm for the fishermen's. It's one example I'm saying. Like RFID we can use for libraries and other applications. Wherever many places RFID tags are using, and even in your ID cards they can use it of. Okay, everywhere we are using of RFIDs, and then the wireless sensor networks. And today, if you see that offer, we are going towards that, not towards last 7-6 that means last 10 years itself it's slowly coming, but especially last 5 years is drastically grown internet of things. Okay, we are trying to control by means of that means your internet itself, even we are monitoring that is your home, that means automations, whatever maybe you are, if you feel that of I don't know whether I switched off my this one for anything, any items I'm not switched on or switched off, I don't know, you can controlled by sitting in your office itself. So that is possible, and whenever, for example, now they are saying that of, I think so. You people are come across with a small project with your BTech student. There will be of a smart helmet. They call it as whenever that they hit very hardly into the ground, then automatically it sends some SMS to that of that is a person, and that is a immediate person which is known to you, and or emergency call. It will make a call, and then it call the ambulance. If you are hit the that is your helmet itself very that is hard enough. So what they're trying to, they're trying to connect through that of the internet. That means nowadays we are going towards a very smarter. Okay, just I'm going to discuss of these three, and especially about the internet of things actually. So I don't want to waste much time about that of RFID. That's naturally that is there will be a reader will be there, and these are all you're all are come across. One of the example I already told that of few examples I told from the library to the top of your car or anywhere we can use it of in the ID card. Everywhere we are using the RFID tags actually. Okay. So this is a very simple RFID. Okay, from this RFID, and we are connecting off many things that is we called as wireless sensor networks. We are going on to that. Okay, this is specification of, because I'm running out of the time, because I know very well this our plan is that of 12 to 1:30. Now it's already 2 o'clock. At least by 12:20 I have to winding up, because everyone has to go for the lunch and other things. Okay, fine. This is the basic things for that of RFID, and that's why I'm saying we directly go to that of IoT itself. Okay. WSN plus RFID, okay, that is will be the future. Okay, what is that of in the future? What is that? RFID infrastructures for the interconnection of the autonomous low-cost RFID based sensor nodes has been proposed. See, very simple. Yearly, what we did, the sensors are placed, and then we have to collect the data, and then we have to take the decisions. So now RFIDs and the WSN all together, and we are going to start monitoring the things actually. So, and this will be connected, okay, to the through the internet and other things actually. The smart object is a cyber physical system. Okay, you can read it off this one. So what we are doing here in the IoT actually, Internet of Things, especially today, if you see that of the security and the safety, both the things, security and the safetyness, this plays a vital role, and other commercial applications also. It makes very easier to everyone because the monitoring is a very bigger thing. Even though it is automation, okay. So I have to go into that place. I have to check. That is different. But in the place itself, I can able to control wherever I want. I will go. It doesn't matter. I can monitor. I can control the things. That will be very smarter enough than that of anything. That's why we are going towards sort of IoTs, that Internet of Things. Okay, so we are more moving towards this one. Okay, so the low power wireless communication, no need of physical connection. That's why I'm saying no need of physical. That means we are getting the data and everything. Okay, so wireless will be there, and we can anywhere we can access. Okay, so GPS make a smart. Okay, this is a secondary one. Okay. And goal for the goal, what is the goal of this one actually? So automatic smart object has access the domain specific knowledge, okay, and then it is empowered with the reasonable capacities, okay, that means capability that is selecting the application domain, okay. So there are many awareness also is there, okay. So before I'm going to conclude of that means many things that is already it is that, okay. We are using and many project also you are come across. For example, if I'm saying the smart city, they call it as, and then a smart village, something they call it as a smart, they including the word. But how the smartness is coming in terms of IoTs alone. In sense, yearly individual products are there. Now all the products are combined together, and it will be controlled by from anywhere in the world you are. Okay, so that is possible in the IoTs actually. That's why today one of my last year BTech student is the smart village they are trying to propose. That smart village in sense all the light will be on time and light will be off on time, and then it should be off everything, the garbage collections, and then in the garbage collections what is that green and then red will be there, and everything will be monitored again and again. Everything is monitored, and it will be connected, and it will be given to that of the internet, so we can easily monitoring the systems. Okay, nothing else. It is slowly growing. It is not a single day it is coming into the world actually. It will be working on many places. Okay. One thing I like to go, because before going to winding up, a few things I like to share it off to you people. Okay, because we are discussing. Actually, I want to make it of a lot of things to you, but due to that of somewhat we are late for half an hour, we are not able to go with that one. I try to correlate of this one with you people sharing of there is a traditional embedded system, and then we are going with that of ASIC or SOC actually. That is a difference. But everything, since this is a very optimal place, because here they call it as VLSI and embedded system. That I try to give the how we have to go to selection of either purely embedded or more on the hardware. You just see that of this is a traditional embedded system that already given the example with the camera as an example, because several IPs are there, and if you are using of several IPs as a chip and it is integrated through the PCB board, it is embedded system. but everything will be integrated into a single ICs. This is ASIC domain. Same thing. We are going to do it. In this, you can see that we are, but now it is not a problem because last 10 years mixed IC designs are going like anything. Mixed IC design means in a single ICs we have both the circuits actually. So, but here it is a traditionally we are removing off that means the analog into the different part. Okay. Along with that of analog and the power, we are removing actually. And some of the things consumes of more area. For example, memory consumes of huge areas. So that is also I am going to remove. So, and rest of the things here is consists of CPU along with the clock generator circuit and then timer, everything are different IPs, you can call it as. Everything I try to integrate in a single ICs. And then I'm connecting off the same power supply and then memory and everything. So this is what will happen with this one. Miniaturization is possible. Okay, but again and again there will be plus and minus is always is there. Okay, so this is I try to correlate of traditional embedded systems and then purely you're going for the hardware actually. And before going to leave, I like to share it off one more thing. Actually, this is yes, please. This is frankly speaking. Today morning, I received with my student. Okay, because I feel he did some. Well, first I'll try to show it off the PPTs. Okay. Just a minute. Just because we can't expect more on that UG project. Okay. So first I can show it off. I'm not going to take much about that, but sorry, sorry. Just just I'm going to run the slides and then I'm going to show that of what are the demo things the student has coming out actually. Very simple. Already you are all have the product of each colleges and then each institute and then everywhere we are having. But we have to appreciate the people, at least they can reproduce that of same kind of things actually. This is he made it off for his project, minor project. Okay, I'm just running out of that slides alone, and then I can give the demo actually. Okay. So these are the things they are using more on sensors and then microcontroller, nothing else. And then web camera they have to use and then IoT model because they have to report if anyone is not following the rules and regulation while entering the things, it will be goes to the authorities. Okay, in terms of message or in terms of something, in terms of message it is going actually in our things. Okay, so this is a hardware he is using. Okay, just I'm running out, but I can show it off the demo. That is that thing also. This is my own student currently working on that UG, but I really appreciate at least for this, even though the lockdown, they are not entering into the college, they have to working for some extent, their product, they are using, they are doing their own product without going anywhere, just purchasing something and then they're trying to do. I can show it off the demo. Really, a little bit I'm interested. I don't know whether you are appreciate or not. That is up to that of the level you have, whatever maybe you feel maybe a very small thing, but not doesn't matter. But I appreciate the person because of this time he is working things. See here. Just a minute. Hope you can visible. And just you try to something. It's again a sensor. Okay. So if you are making, they will making of. But again, you have to say embedded system means somehow you are mechanical. Also, it should be there. You should be see how you are using for the mechanical for his own. He is using on his own making of that has to be mask has to be come out actually. He is making, but because his creativity is using okay. They're trying to do something. It's a small sensor. It is using actually. But today it's very simple because we are using Android, but Arduino boards are there. It can be easily done. I am also come across many project with this one. Okay. Just a minute. I have some problem in that. Sorry. So just very simple, they want to do it in the 3 times, and we are to say that if the less than 3 times is there, it will be sent the indication also. Okay, this is up to this one, it is embedded only, no doubt about that. And it will send the signal to the people also. The next one, it is like that only. Okay, the next one is the webcam interface also they are making actually. Nowadays, this is also they are trying to give it. Just a minute. Last one, I try to share it off. So some person is entered, it will be sent to the warning to the the person also, some authority person also, the warning is sent to them. So they're connected actually. So very simple. That means same what I kind of say today. Many applications are coming. Yearly, I told that's a simple. I really why I'm showing off this one. At least of the students are start doing, and nowadays it's very simple because yearly we are using of microcontroller, but last 10 years we are using of very simple Arduino boards we are using. Only the thing is that we yearly I won't appreciate also the people. Now if people are doing with the good applications. Really, they let them learn something actually. UG minor project, let them do something actually, not at all issues. And maybe I'll winding up this one because everyone is very. I know very well it is only introduction, but problem is that it will be extended. So your lunchtime, won't take it off much. So I'll just give it back to the coordinators. And if you have any doubts, please come out. We'll discuss. If you have any doubts, any clarification, you can type it on the chat box. I'll try to explain.
Professor, thank you for your valuable and informative session. Participants, if you have any queries, you can put it in the chat box. Attendance link will be shared in the chat box. Kindly fill it up. Next session will start by 2:30 p.m. Participants are requested to join before 2:30 p.m.
Thank you, sir. Thank you very much. Thanks for this opportunity. I like to thank the that is IIIT Trichy director and the Professor Dr. G. Sitaraman and Madam Dhanalakshmi Madam for this opportunity. I know that I am running out of the time because I also have the constraint. I planned for up to 1:30. So due to the slot, I will know very well not able to make it off the in depth of the things. Just like of eye opening, I try to give it off. Anyhow, the full the presentation, I like to share it off with the coordinators, and they will share with you people. Actually, not a problem. We keep in touch. Thanks for this opportunity. Thank you all. Thank you all. Bye.
Thank you, Vaidyanathan sir.
Thank you, sir. Thank you, Professor.
Thank you. Participants are requested to join by 2:30. Okay. Professor Bhaskar is the next speaker.
చెప్పండి ఇది కమ్మీ అండి 49 family pack means 2 person. 2 person means